In this video, we're going to review average rate of change. And keep in mind that average rate of change is basically the same as finding the slope. So to find the average rate of change, we're going to use the same formula that we use to find the slope. Right here, so if we have a linear function, it tells us in a linear function, your average rate of change or your slope is going to be constant. Okay, so that means between any 2 points that we pick on the line, you're going to get the same slope. So here, between this point and this point, it shows you that they got a slope of 2. And then we go up higher and we select this point and this point, and we still get the same slope of 2. So with any linear function, linear meaning a straight line, your slope is constant. That means the slope stays the same. So this slope is 2 over 1. So that means from this point, I can go up to right 1. I can continue. I can go up to right 1 again, up to right 1, up to right 1. So in a linear function, the slope is constant. The slope is always going to be the same. And your slope is the change in y over the change in x, which is the same as the average rate of change. Now we have a non-linear function. All right? So this is an example of a non-linear function. Non-linear because the graph is not aligned. When you're finding the slope of a non-linear function, the slope is not necessarily constant. That means between any 2 points, it's possible for the slope to be something totally different. So in the example here, start at this point and this point, and they show you that the slope there is 1. But when I go between this point and this point, now the slope is 3. So all 3 points are on the same graph, but it's not aligned, so it doesn't have to be the same. And to find the slope, this is what's very important here. y2 minus y1 over x2 minus x1, or the rise over the run. So here we could count up 1, right 1. So that's rise over run, that's 1 over 1. Or here we could count up 1, 2, 3, and then right 1. And that's how they got to 3 over 1. All right, so now let's look at some examples. It says to find the average rate of change. So what I want you to get in the habit of doing, whenever you read average rate of change, let's go ahead and write down that formula. Now, keep in mind, in order to find the average rate of change, you got to have 2 ordered pairs. Okay? Now, in these ordered pairs, we can call this one x1 and y1, and we can call this one x2 and y2. The 1 and the 2 just indicates which ordered pair the coordinate came from. So both of these are 1s, so that means this is my first order pair. Both of these are 2s, that means this is my second order pair. So now let's go back to the problem. It says to find the average rate of change over the interval 1 is less than or equal to x is less than or equal to 3. So what they're giving us here, they're giving us x values. All right, they gave us an x value of 1 and they gave us an x value of 3. So we're going to use this table to find the ordered pair. So when my x is 1, from this table, I see that my y is 4. And then the second one, when my x is 3, here, it shows that my y is 16. Now I'm going to label these. This is x1, y1, and this is x2, y2. I'm going to substitute into the formula. So m equals, in the place of y2, I'm going to put 16 minus y1, which is 4, divided by x2, which is 3, minus x1, which is 1. 16 minus 4 is 12. 3 minus 1 is 2. So 12 divided by 2, which is the same as 6 over 1. So my slope, we can write it as 6, or we can do 6 over 1. So that means I'm going to rise 6, run 1. All right, in the second example, it's a little different. We don't get a table. Here they give us an actual graph. Now, it says find the average rate of change. So I'm going to write m equals y2 minus y1 over x2 minus x1. Now, my x values that are given to me, I have a 1 and I have a 4. And I got those from right here. So, this is x1, and I got to find the y1. This is x2, and I have to find the y2. So I'm going to go to my graph, and it says here that my x is 1. So I'm going to go over here to x is 1. Right here. When x is 1, I have to go up here to get on the graph, and y is 1. So when x is 1, y is 1. So this is it, 1, 1. Now I'm going to do the same thing with 4. So I'm going to go over to 4. This is 4. And now I'm going to go up. And that's the point where I land on the graph. So now, when x is 4, y has to be 2. So I'm going to put 2. Now I'm going to use my formula. M equals y2, which is 2 minus y1. x2 is 4 minus 1. 2 minus 1 is 1. 4 minus 1 is 3. So your slope is 1/3. All right, so now this time we have a word problem. And it says, finding average rate of change from a word problem. A ball thrown in the air has a height of h of t equals negative 16t squared plus 50t plus 3 feet after t seconds. What are the units of measure for the average rate of change of h? So it tells me here that t equals seconds. So h would be the height. Right? So, and then the height is going to be measured in feet. So one thing to keep in mind, whenever you have an ordered pair, it's always time is your x coordinate, and then the units will be your y coordinate. So for this problem, the seconds are going to represent x, and the feet will represent the y. All right, so it says to find the average rate of change of h between t equals 0 and t equals 2. So t equals 0 is my x value. I got to find the y value. To find it, we're just going to use this equation. So I'm going to do negative 16 times 0 squared plus 50 times 0 plus 3. 50 times 0 is 0. 0 squared is 0 times negative 16 is 0. So that means my y value is going to be 3. Now, for t equals 2, I'll come over here and I'm going to do t equals 2. So it's going to be negative 16 times 2 squared plus 50 times 2 plus 3. So this is negative 16 times 4 plus 100 plus 3. That's negative 64 plus 103. That gives us 39. So my second order pair, when t is 2, we get 39. So now we can label these x1, y1, x2, y2. So now, in my formula, that I didn't write down yet, m equals y2 minus y1 over x2 minus x1. So m equals 39 minus 3 over 2 minus 0. 39 minus 3 gives us 36 over 2, which gives us m equals 18. And that's 18 feet per second. All right, so my units on the top, that's your y value over your x value. For this particular problem, that's feet over seconds. So that's why I expressed my answer as feet per second. That's your average rate of change. Now, let's look at a problem where it's not given to us in a word problem. So let's just say we have negative 5 and negative 3. It's my first order pair. And my second ordered pair is -4, -9. And we're going to find the average rate of change. So what we do know is that this is x1 and this is y1. This is x2 and this is y2. If we're finding the average rate of change, then we're going to write m equals
I'm sorry, I thought I
y2
had cut it
minus
off.
y1. You find x2 minus x1. So now we're going to substitute into our formula. We're going to put a box here for y2 minus a box here for y1, box here for x2 minus a box here for x1. So now we're ready to do our substitution. In the place of y2, we're going to put -9 minus y1, which is -3. x2 is -4 minus x1, which is -5. So now we have to remember our rule of integers. Add the opposite, add the opposite. And now we're going to combine. -9 plus 3 is -6. -4 plus 5 is +1. So your rate of change or your slope is -6, or you can express it -6/1.